So the next topic which we are going to deal is what will be the potential energy in an external field due to a dipole. That is potential energy due to a dipole in an external field. I hope you remember what the dielectric dipole was. It is a collection of two charges, plus q and minus q of same magnitude, and they are at a distance 2l distance or at any distance between them, right? And earlier we had derived many things regarding this electric dipole, and we also had dealt what happens when an electric dipole is kept in an external field. What happens? And I hope in this diagram also I will write AB dipole, and at one point I will be writing it as plus q and the other end it will be having minus q, guys. And the distance we always take it as 2l because it is better to make 2l, so that when we make it half it will be L and L. So suppose this is your external field and I am going to keep a dipole here. Suppose this is your dipole, right? So this is A, B, this is plus q and minus q here, and the length is 2l, right? And theta is the angle this dipole is making with the electric field. It is same as that of the earlier scenario. There is nothing much change. Now we know this end will be having a force in this direction. Why? F is equal to QE, right? That is Q plus Q means it will be having same direction. Whereas in this end, F will be equal to minus QE. That means it will be in this direction, that is opposite direction. F is equal to minus QE, right? I hope you remember these things. So I'm going to redraw here. So here it is F and the other F is in opposite direction. So what happens? These two F net, not net force on this dipole will be 0 because both of them are in opposite direction. They cancel it out. So they are going to undergo what is known as rotation, hence a torque. I hope this and all have been already taught, guys. I'm just making you sure. The expression also you would have learned it as torque is equal to P cross E. Cross product means it is which PE sine theta. And I also mentioned you are supposed to write P cross E, not E cross P, right? So torque is P cross E. So I'm going to write it in the vector form, that is PE sine theta also. And what is theta, guys? Theta is the angle the dipole is making with the electric field. Now these and all things which has been learned, we have just refreshed with this equation. This equation is required for the further calculation for potential energy. Now what we are going to find is sum of the parts. First we will go for some subtopics. Then we'll go for the conversion or finding potential energy. First is work done. What work is to be done when this torque is going to rotate? That is work done in rotating the dipole, right? Work done, I hope you remember the expression. What was work done's expression? What was the expression for work done? It is force into distance, right? But what type of work they are happening? Here it is going to rotate. So there is no force here, right? But yet we am telling there is work. So the work is done by what motion? Rotatory motion. There is no translational motion, but there is rotational motion. So here again I'm going to draw an electric field and I'm going to draw a dipole like this, and this is A and B. This is angle theta. Same diagram. Now what I'm going to do is in this external field E, I'm going to make this dipole to rotate. Before rotating, I'm just going to give an anti-clockwise movement. Suppose the dipole is rotating in such a way that from theta it is going to increase. That is, it is going to move in anti-clockwise direction. So that its now position is A dash and B dash. Suppose it swept an angle of d theta. Slight angle change, right? So if B has moved to B dash, don't you think theta would have increased? Yes, the angle would have increased, right? And then also there is a torque and there is a work done. So what was the expression for work? It is force into displacement. Here in place of force, what expression you are supposed to write when it is rotating in this direction? in which direction it is moving, guys? We are making sure that it is going to rotate in anti-clockwise direction. So small work dw is, here the force is torque, so it is torque. Why I'm writing torque? I hope you remember. Torque into displacement is angular displacement, which is d theta. I hope it is clear. Right, in place of torque I can write the earlier expression of PE sin theta. I am going to mention again how it is going to rotate. It is going to rotate like this, right, and it is just a small angle, and this d theta can increase further as the angle of rotation or rotation increases. I hope clear. Right, now in torque I am going to write PE sin theta into d theta. Now guys, this work is very small, right? I'm going to sweep this dipole throughout, right? So I am going to do a large work. When I sweep it through 360 degree, that means I'm going to do a lot of work. So I require W. How can I find W? I will integrate dW, right? So in place of dW, what would I write? PE sin theta d theta. Now the problem comes, there should be two limits, right? From where to where I'm going to rotate. I'm going to rotate from another angle theta 0 to theta 1, can change whatever. This theta 0 can be any initial angle, right? Theta 0 to theta 1, PE sin theta d theta. Clear? Now here PE is a constant variable. P and E, I can put it outside. Theta 0 to theta 1 sin theta d theta. Now guys, what is integral sin theta? What is integral sin theta? Guys who know maths can give me the answer. It is minus cos theta, or in x it is in the cos x form. So I am going to replace sin theta with what? Minus cos theta. So it is PE minus cos theta, upper limit theta 1, lower limit theta 0. Now what is now the expression? Now we have to put upper limit minus lower limit. I'm putting minus outside, okay? So it becomes cos theta 1 minus cos theta 0. Right, now I'm going to bring this minus inside. So it becomes what? PE cos theta 0 minus cos theta 1. Clear? So what do you mean by theta 0 is the initial position, right? Suppose I am going to consider that this is my electric field and I am going to keep this dipole in such a way that this is AB, like this, straight. So what will be the angle between this electric field and the dipole? It will be 0. So initially I have just kept the dipole like this, right? So this theta 0, I am going to take it as 0 degree. Right, so that what would the expression of WB? I'm going to substitute this value here. It is PE cos 0. What is cos 0? It is 1 minus cos theta 1. I'm going to take this theta 1 angle, something, theta, just any angle. So this expression of work becomes this. PE into 1 minus cos theta 0 is 0, that is 1. Right, minus cos theta 1, in place of theta 1 I wrote some angle theta. Now we are going to consider some cases. Case 1. Right, case 1, that is, this is your dipole which is already making an angle 0 degree and you want to rotate in this direction, so that now this is making angle 90 degree. Initially, sorry, 0 degree. Now I want to keep the dipole in this direction. I am rotating like this. I rotate it like this. So initially the theta is, or theta 0 is 0 degree. Now what is theta 1? It has become 90 degree. Or 0 is initial, right? So it is already 1 cos theta. This theta has become 90 degree. So that what will the expression be? PE 1 minus, what is cos 90 degree? It is 0. So it will be PE. That is your case 1 condition. That is, if you are rotating a dipole from initially the position 0 to 90 degree, its work done will be PE. Now what is case 2? I am going to rotate now this dipole initially this position, then 90. Now of course I am going to find this angle, right, when it is in this way. So what is theta 0? Again, initially it was at 0 degree. Now what is theta? What is the final position? Right, suppose again I'm going to draw the diagram so that you understand the scenario. This is your electric field direction. You want the dipole now in this direction, right? In here, like this, like this, like this. So it is what? Angle theta becomes 180 degree. I'm going to substitute this value here. So WPE 1 minus cos 180 degree is minus 1. So it becomes 1 minus minus 1 becomes 2. So work done is 2 PE. Clear? Now case 3. That is again theta 0, that is initially it is in a straight position, and I'm now going to rotate it 360 degree. That is, it is coming to its initial position, right? One rotation completed. It was here like this, then like this, and like this. Now it is coming back like this. It is coming to its initial position. This is its initial position, right? So again I'm going to repeat it. Initial position goes like this. Now again, right? So the theta becomes what? 360 degree, right? So PE 1 minus, what is cos 360 degree? It is 1 itself, so 1 minus 1 is 0. So work done is 0, right? That we already knew. You need not write the expression for a rotatory or one complete cycle, one complete rotation. The work done is 0. Clear? See, we found work done here. But actually, what is the topic? You are going to find what? Potential energy due to an electric dipole. So expression is not complete. There is further derivation to be done. I am going to find what? I am going to find potential energy there. So you have to remember what the expression or what was the definition of potential energy. What was potential energy? Work done, right, to move a charge from infinity to a point, right, from point. So what is the specialty of infinity? That the potential is 0, right? So can't I remodel the definition of potential energy as work done to bring a charge from 0 potential to a desired potential, right? Desired means this point is usually P, remember? So and the potential at P is PP. So I want to bring a charge from 0 potential to a desired potential. I want the potential VP, right? That is another way we can say the definition of potential energy, right? So we come back, guys. What is work done's expression? Integral theta 0 to theta 1 PE sin theta d theta. We wrote this expression, remember, in the previous section. You can just go back. Right. Now what is the initial and final position? See, remember the scenario. Always we want to bring a ball from 0 potential to very high potential. So always we have to find work from 0 potential to maximum potential. So can you say when this is your electric field, in which condition the work done or the potential energy is 0 for a dipole? It is this condition. This is the dipole. The force will be in this direction. Right? Remember, F is equal to QE. F is equal to minus QE. They equally negate each other. At that time, the net force is 0. Right? Net force means 0 is indicates there is no work done. So there is no work done means there is no potential energy. So this angle is 90 degree, right? So the angle which the dipole makes with the electric field is 90 degree when the potential energy is 0. So can't I take theta 0, that is the initial position, as 90 degree? I hope it is clear. Why did we take the initial position as 90 degree? Because that is a position where the potential energy is least, right? So again I'm going to write work integral 90 degree to some angle theta, I don't know, P is sine theta, d theta. P is constant, integral sine theta is minus cos theta. I'm not going to write the derivation again, guys. This is something I took earlier. Right, upper limit minus lower limit is PE. I'm going to write the minus outside. Cos theta minus cos 90 degree. What is cos 90 degree? It is 0. So it becomes minus PE cos theta. This is the expression for work done for a dipole in an external field. Right, again guys, work done is equivalent to what? Potential energy. So this is the expression for potential energy also, and is PE cos theta. PE cos theta means it is a dot product. So it is minus P dot E. These two vector quantities are multiplied in dot product way, means potential energy is a scalar quantity. Hope it is clear. Right, now we'll go for a numerical problem. Right, so a numerical problem, please write it down as I am showing. And the problem is, suppose you are given 4-point charges, 1 microcoulomb each, are placed at corners A, B, C and D of a square of side 0.1 meter, and you are asked to calculate V at O of the square. So we'll go for the first part, then we'll go for the second. So you're given 1 microcoulomb charges are placed at 4 corners of a square, and you're asked what will be the potential at the center of the square. Right, so we'll solve for the first question. It is part A. I'm going to draw the diagram so that we can understand it. This is your square, 1 microcoulomb. Suppose this is A, B, C and D, and you are having 1 microcoulomb each at one point, and all of them are positive, and this is 1.1 meter, 0.1 meter, 0.1 meter and 0.1 meter. Right, this is your figure, and this becomes your center because square means center is where the diagonals meet up. This is your center. So you're asked what is VO. You're asked what is VO, potential at O. So what will be potential at OB? It will be the contribution of potential due to A, B, C and D. That is, VO is potential due to A, potential due to B, potential due to C and potential due to D at point O. That is, this A will be causing a potential, B will be causing a potential, C as well as D. Right, and this entire sum is a potential at O. So I wrote it as VAC. I am going to write VA is potential at O due to A. Similarly for B, C and D. Clear? Right. So what is VA? What will be the expression of A? Its potential B. It is 1 by 4 pi epsilon naught. Right. Q, that is, this charge is causing the potential, that is 1 microcoulomb divided by, what is the distance? AO, R, right? About this expression, I hope you remember what is expression for V, 1 by 4 pi epsilon naught, Q by R. Here Q is A charge, 1 microcoulomb, R is the distance between the 2 points, that is AO. So what is AO? What is AO? That is half of the diagonal of a square. So if you remember that expression for diagonal of the square, it is well and good. If you have not found it, you can just use Pythagoras theorem. Right? Suppose this is 2 sides of the square. So this will be root A squared plus A squared. It will be root 2A. How you just find. Right? So I can say from this figure, AC is root 2A. Right? So what will be AO? AO is AC by 2, half of it, right? That is root 2A by 2, or I can cut it off, or AO is A by root 2. That is the final expression for half the diagonal. Either you can by heart it or you can derive it. I will recommend that you by heart it. That is, from one point to center of a square, the distance is side of the square divided by root 2. So here side is 0.1, right? Clear? Right. When you calculate, you will get around A is how much? 0.1 divided by root 2. It is 0.1 divided by 1.414. Right. You will get around 0.07 meter as a value. Calculate it, guys, by yourself. Right. Now, I'm going to put this expression or value in the earlier expression. So that what will be VAB? 1 by 4 pi epsilon naught. 1 microcoulomb is 1 into 10 to the power minus 6 divided by OA is 0.7 meter. It is good that you are given meter. Suppose sometimes it is given in centimeter, you have to convert it back. Now VA is this much. What will be VBB? VB is also the same distance from O and it is also having the same charge. And you can see C is also having the same charge and same distance from O, and D is also same charge from same distance from O. So can't I write VA has been repeated again and again, or I can write VO is equal to VA plus VA plus VA plus VA, because VA is equal to VB is equal to VC equal to VD, because all are same value charge and equidistant from the point O. Right. So I'm going for the equation again, guys. So what will this expression become? What will this expression become? VO is equal to 4 VA. So what is VA? 1 by 4 pi epsilon naught 1 into 10 to the power minus 6 divided by 0.07. And after calculating, you will get the values around 5.14 into 10 to the power 5 volt. Calculation, you guys can do it by yourself. Right? That is the first part of your numerical question. Now let's move on to the second part of the numerical question. That is B. What the B part is. You're given if E is the middle point of BC, what is the work done in carrying an electron from O to E? So guys, you have to draw the diagram again. This is your A, I think. This is B, we mark like this, right? C and G, right? And E is midpoint of, and goes O here, right? Suppose this is O, right? Now question again, if E is the middle point of BC, and what is the work in carrying an electron from O to E? Because I want to bring an electron from O to E. This is the question, what work I am going to do. See, when I want to move a charge from O to E, I have to find work done, means it sense it is potential energy, or I can say potential difference in the charge. Right. So what is the expression for work done? I hope you remember, that is charge into potential difference. Right. What potential difference you are having? 2 points, right? You are going to bring charge from O to E, means which is having higher potential, E. Right. So Q into VE minus VO. I hope this is clear why I wrote higher potential is at E. When you bring a charge from one point to another, the point where you are bringing charge is having higher potential. Right. In place of Q, I am supposed to write E, charge of an electron, VE minus VO. That is the work done at, or bringing a charge from O to E. Now out of this VO we found earlier, right, around 5.14. Right. Now electrons, now your problem is what is the value of VE? What is the value of VE? How would I find? So I am going to redraw the diagram again. This is point E. This is B, C, A and D. I am going to find the distances. This is 1 meter, right? This is 1 meter from B to C. So this becomes 1 meter, right? 0.1. This becomes half, so it becomes 0.05. It's 0.1, 0.1. What is this distance from A to E? and D2. It is very easy. Consider a triangle. You can understand this side and this side is equal, right? AE is equal to DE. Right, that is easier to understand. How can I find AE? Triangle A, B, E. This is A, B, and E. B is 90 degree, right? And B is given as 0.05. AB is 0.1. So what will be this? Root of 0.1 square plus 0.05 square. Find the value. You will find the value as around 0.1118. Right, that is the value of AE. You guys can calculate it by yourself. So DE also will be 0.1118 meter. Right. So now we are going to find what is potential at E. Right. There is a question. What is the potential at E? Potential at E is due to what and all charge? Potential from A, potential from B, potential due to C, and potential due to D. Right? So what is potential due to A? 1 by 4 pi epsilon naught Q, that is charge at A, is 1 into 10 to the power minus 6 1 microcoulomb, right? We have charge 1 microcoulomb there. By R is distance AE plus VD 1 by 4 pi epsilon naught. So I'll write it like this, guys. That is VE. VA is this. VB is charge, it is 1 into 10 to the power minus 6 at point B also. Distance between B and E is 0.05. Oh, I will write the B later on. We will substitute the values. VC is 1 by 4 pi epsilon naught 1 into 10 to the power minus 6. Distance is I'll write it as CE. Then VD is 1 by 4 pi epsilon naught 1 into 10 to the power minus 6 divided by the distance is how much? DE. Now substitute the values. AE is 118, I think. 1 by 4 pi epsilon naught 1 into 10 to the power minus 6. BE is how much? 0.05. Similarly 1 by 4 pi, 4 pi epsilon naught 1 into 10 to the power minus 6 divided by 0.05. I'm just putting the values. 1 by 4 pi epsilon naught 1 into 10 to the power minus 6. DE is 0.1118. Just calculate it. It's easy if you make the things which are common in one side. This and this term is same. Right. So 1 by 4 pi epsilon naught, same term twice. 1 into 10 to the power minus 6. 1118. 1 plus 1, this becomes 2. Plus this and this is again twice. So 2 into, or I was write it as 1 by 4 pi epsilon naught 1 into 10 to the power minus 6 0.0005 into 2. Right? Now you have to find the values. Right? It's very easy. These two terms are same. 1 by 4 pi epsilon naught 1 into 10 to the power minus 6 into 2. 1 divided by 0.1118 divided by 1 divided by 0.05. Now you can find the value, and you will find the value of the entire expression as 521,010 volts. Right, that is a value of potential at E. Now what the main question was? The main question was, what is work, right? And what was the work done? Minus E into VE minus VO. So E minus E, I'm going to write the equation again. It is VE minus VO. What is electrons value? 1.6 into 10 to the power minus 19. VE, we just found the value 521010. Earlier you had an expression of 5.14, right? 10 to the power 5. So 5 decimals come up in this side. So it becomes 514280. and the correct answer will be 1768 into 10 to the power minus 19 joule. The calculation you guys have to do it by yourself, right? I will tell you how to find that answer. That's it. Clear?